Hi everyone and welcome. If you have such a requirement in which you want to read Modbus serial device data and you want to publish that Modbus serial device data into any OPC US server, then we have one solution for you. Okay, we have created one application. That application will read the data from your Modbus serial device and it will publish your Modbus serial device data to OPC US server. Okay, and you can read those data in any of the OPC UA client. In this case, our application will not create OPC US server. Okay, our application will connect with existing OPC US server and it will publish the data on respective namespace and node ID. Okay, so let's see our application, that how it is going to work. So you can install that application in your system. So I have already installed that application in my system. You can see Modbus serial to OPC UA converter. Okay, okay, here is the application. So first of all, you have to provide your Modbus serial data. Okay, which data you want to read, a number of register you want to read, and then after you have to provide your OPC US server detail in which you want to publish your data. Okay, so my Modbus serial device is available at the COM2. Okay, so here I have to select COM2. Now the baud rate of my serial device is 9600, parity none, the flow control is also none. I want to read two register. Okay, and starting address is 0, Modbus device unit ID is 1, and I want to publish Modbus data at OPC US server at interval of 1 second. Okay, so that I have to specify here. And which data I want to read, I want to read the holding register or input register, that I can select it from here. So right now I want to read the holding register data and then I want to publish that data to OPC US server. Here is my OPC US server, which is process OPC US simulation server, and in the objects I have created two variables, holding register 0 and the holding register 1. For the holding register 0, the namespace is 3 and ID is 1010, and for holding register 1, namespace is 3 and ID 1011. Okay, so here I'm going to read the two register. So first register value will go to HR0 and the second register value will go to HR1, which is namespace 3 and ID 1011. Okay, so all those things we have to specify in this software, and also we have to copy the endpoint URL of your OPC US server and you have to specify it here. After that, if you have any client certificate, then you have to provide it here. You have to select the security policy and the message mode. You have to provide username and password if there is any username and password to connect with your OPC US server. And then after, you have to provide your namespace detail and ID. Okay, so namespace is 3, as you can see on the OPC US server. Namespace is 3, so that is why I have provided namespace 3, and ID is equal to, and we are setting the offset to 1010. Okay, so the first register uh, data will be available at 1010 and the second register data will be available at 1011. So that is why I have to set the offset here. So it will read the data from my Modbus serial device and it will publish the data here. Okay, so here is my Modbus serial device. It's a simulated serial device, so I can simulate the values like this. Okay, auto increment, and I will write 50 and then I'll auto increment here. Okay, so now this two value is auto incrementing. Now I want to publish this value to OPC UA server. Okay, now everything is configured in this system. All I have to do is I have to press this run button. Okay, now it is reading the data and you can see it is writing the data on namespace free node ID 1010. If you see here, you can see 63, 65, 67. Okay, all those data available here, and also you can see the values here. Okay, it is lagging because it's a Modbus serial communication, so that is why Modbus serial communication is very slow. So that is why it is taking time to read the data, and then after it is taking usual time to publish the data to OPC US server, and that is very less time. But reading the data from Modbus serial device is taking longer than expected because of serial communication. Okay, now if you want to see the second data, you can see on 1011 we have this data. Okay, ID 1011 we have this data. you can compare this two data here. Okay, and here is our actual data. So this is how you can use our application Modbus Serial to OPC UA converter to read data from any of your Modbus Serial device, and you can publish your data to OPC UA server. And we are not creating OPC UA server inside our application. We are using third-party OPC UA server to connect with that OPC UA server, and inside that OPC UA server we have this kind of variable already created, and we are publishing our data on those variables. Okay, we are updating the data on those variables. If you use OPC UA expert, okay, and cancel, add, here we have process. Okay, let me add process for, okay, advanced process, and okay. Okay, in the simulation we have holding register 0 and the holding register 1. Okay, here you can see the current value, and here you can see the value from OPC UA server, and here is our OPC UA server up and running. Okay, I can minimize this because there is no need of it, and here is our main application, which is reading the data from this device and publishing the data to OPC UA server. So this will continue publishing your data to OPC UA server until you keep this application on. Okay, if you want to customize this application as per your requirement, then also we can customize it. Okay, if you want to use this thing as a static thing, okay, you don't want your user to change those things, then also we can do it. Okay, now instead of here right now we are reading the holding register data, but instead of holding register, if you want to read input register data, and if you want to publish the input register values, then also we can do it. Okay, so let's go to our OPC UA server, and here you can add a node. So it's input register 1. Okay, we will start from 0, and here we will use 20 1020, and the data type double. Okay, double, add. So it's our IR0, and we will add one more, which is IR1 and 1021. Okay, and the data type is double. Okay, we have created IR0 and the IR1, and the IR0 has starting node ID is 1020. So the following IR1 has ID of 1021. Okay, now if I rebrowse, okay, IR0 and IR1, right now it has null values because we are not publishing those data. Okay, so what I have to do is I have to go to my application, I have to stop it. Okay, I have to select the input register, and our data is going to publish at node ID 1020. Okay, and then 1021. So here instead of 1010, I have to use 1020. Okay, and the preset is fixed, namespace free, and ID is fixed. Okay, we are providing node ID as an integer, we are not providing node ID as a string, so that is why this is fixed. So all done. I have to just change to input register here. Okay, here right now 50. Okay, so both values are simulating. I can start this process, and you can see the value is updating here, 11021 and 1020. You can also see the values here. Okay, so this is how you can use this application Modbus Serial to OPC UA converter to read data from any of your Modbus Serial device. It will read data from your Modbus Serial device. It will set the namespace and node ID according to your inputs, and it will publish that data, okay, to your OPC UA server. And here OPC UA server is third-party OPC UA server, so we are not creating our own OPC UA server. We are using any other OPC UA server which is already created in the plant. Okay, and we are creating the tag for our requirement, and we are publishing the values on those tags. Okay, so I hope this thing is clear to you, and if you want to buy this application, then you can visit our Shopify store. Also, I will provide the link of this product in the description of this video. You can go there and you can buy this product. Okay, so I hope this thing is clear, and if you still have any question or any doubt or any concern, then always you can ping me on WhatsApp, Telegram, Instagram, anywhere. Okay, so we will meet you in the next video. Till then, take care, goodbye, and thank you.